All right, welcome to part 3 of the pushing tutorial. So just continue right where we left off here. So now that we know where the character is going to stand and what direction he's going to push it in, before we can just go ahead and teleport him there, we want to make sure that it's a valid place for him to teleport to. Because for example, if this box, let's say, is up against this wall here, and the character walks over and he's standing right here and he presses the button. Well, if we don't do any checks, it's going to teleport him through the wall and he's going to fall and he's going to die and they're going to uninstall the game because it sucks, right? So we don't want that. So what we want to do is we want to make sure that there's enough room over here on the side, whichever side he happens to be teleporting to. We want to make sure there's enough room for him to stand there, right? So to do that, we're going to do a capsule check, basically, based off the size of this capsule. We'll make sure that this capsule around the player will fit over here nicely. So back in our pushable, after we draw this debug sphere, we want to do a capsule trace. And we're going to be doing a capsule trace because we also care about the angle of the floor because, well, I'll explain it later, but right now, let's just do a capsule trace by channel and hook this up. So the start location is going to be this handy little character new transform. So this variable basically represents where he's trying to move to. So we can just drag this guy in, and we can split it because we want to get the position out of it or the location. So we want to start it a little bit above this, and we want to go a little bit below this. So we'll say vector plus, and for the z we'll add like 70, and then we'll also do a vector minus, and we'll do like 100. These are just values that worked well for me. You can feel free to mess with them, but these work the best for me. So we'll hook this up to the start and the end. And then for the radius, we want to use the same radius as the capsule that's around our character, right? So we can say get character, get character, and we want to say get capsule component and type. There we go, get capsule component. And we want to get his get scaled radius, and that will be our radius. And then for the half height, we can do the same thing, get scaled capsule half height, and that would be our half height. And we're doing that so that way the collision that we're checking is the exact same collision as our player, right? Because if this capsule fits, then we know that our player is going to fit as well. And we can actually draw this as well, so we can kind of visualize it. So we'll set the draw time down to like 2 seconds though, because 5 is a little long. And we'll set the draw debug type to for duration, so that it draws for that duration. And then we want to take this value, this out hit result, and we want to break it. And we'll just hit this little drop down here so we can see everything. So this initial overlap boolean is important because if this is true, then that means that when we spawned the capsule, and again, we're spawning it at the player's or at the new transform location, but a little bit above it. If initial overlap is true, that means that the capsule spawned inside of something, right? And that would happen if you're up against a wall, right? Because when you try to spawn the capsule there, it's going to be inside of a wall. So if initial overlap is true, then we want to get out of here. So we're actually going to do a not boolean just so we can keep it as true, and then we'll do branch. And so if it's true, then everything's peachy, right? But if it's false, then we want to print out something. So I'm going to copy this print message again, like so. We'll put that here. And so the reason that we're failing in this case is that there's no room to stand, right? There's not enough room for us. We've hit something, or there's something in the way of where we want to go to, and so it's going to fail and not let you push. And then another thing we want to check is the floor, right? Because if you remember from over here, we have this floor here, or not this one, this one. As you can see, the example is the floor is too steep, right? So there's this floor here, but it's too steep for me to walk on. So it's kind of like a wall, but it's a slightly different case that we need to handle because it doesn't immediately detect that there's something behind me because it thinks there's a floor behind me, but it then realizes, wait a minute, well, the floor is too steep to stand on, so it doesn't let you do it. So we want to check the impact normal, which is going to be the normal of the floor that we hit. We want to break this, so we'll say break vector. And we want to take this z value and we want to compare it to the maximum walkable floor Z value of the character. And you can actually get that really easily. You just say get character and say get character, oops, or just character, what is it? Character movement. And then say get walkable for Z. So this is, if you hover over it, it says the Z component of the normal of the steepest walkable surface for the character. Any lower than this and it's not walkable. So we can say if it's less than this, then we don't want to walk on it. So we'll say if it's less than that, branch. And when the fail reason, again, is floor not walkable. Okay, so if we pass both of these branches, then we know that there is room for our character if he were to be put in the location we want to put him in. And so since that's the case, we can then say set actor transform, set actor transform. I'm just thinking actually, because I realize I might have done this a bad way here, because basically what I have in my other project is I set his location and then I do a line trace to make sure there's not a wall in front of him. But I could probably just do that line trace first and then not have to set him back. Actually, yeah. So we're gonna change this actually. So yeah, so the one case we need to check for here, the reason why we're doing a line trace now is, let me just explain this real quick so that it makes sense. So if you look at my other project, if you have a case like this where there's a wall, but it's a very thin wall, then when it draws the capsule, it's actually going to draw the capsule over here because that's where the thing is, and it's not actually going to be colliding anything because it's actually gone past the wall. And so it's going to think you're good to go, but obviously you don't want to be able to push here because there's a wall here. So even if there's room for the capsule, you still want to do a line trace from the location that you're moving to back to the thing you're pushing to make sure you can see it after you move there. And that's just for this, kind of rare occasion where there's a thin wall in between you and the thing you're pushing. But yeah, so like I said, I had it set up differently before, but now that I'm thinking about it, we actually don't want to set the actor's location. We just want to do the line trace. So we're going to say line trace by channel. And so the starting location is going to be the new location that we're moving to. Or let me think. I have it backwards in my other one. Oh no, so we want to go to the character's location. So drag in the character's new transform and split this. And so that's where we're going to. We want to go from the location of ourselves, which is the queue. So get actor location. Yes. Okay. And then visibility, and then actors to ignore. So when you say make array here, so we want to ignore the character, right? Because obviously we don't care if we hit the character. He's not a problem. So we'll say character. And then let's turn this on for a duration and set it to 2. So that way we can see it. And so basically, if this line trace doesn't hit anything, then we're good, right? Because there's nothing in between the character and the thing he's pushing. So we can say not Boolean and do a branch and hook this up. And we want to again push or print out an error message if this doesn't work out, and say character, or maybe we'll say wall in between character and object, something like that. Okay, but if this is true, then that is actually the last thing we need to check. And so we want to set the actor's location. So we'll say set actor location. And then the actor's location we want to set is the character. So we'll say get character. And his new location, oh, sorry, not location, we want to say transform. So delete that and say set actor transform, because we need his rotation to be set as well, which is included in transforms. So his new transform is obviously just his character new transform over here, like so. And we can select teleport checkbox. And then finally, we want to say, well, actually, that's all we can do for right now because we haven't written that far yet. But one thing we can do is we don't actually need this character previous transform. The reason I had you guys add it is because, like I said, I had previously where I moved him, and then if the line trace failed, I moved him back. But I realized that that's kind of dumb. We can just do this. So come back over here to the beginning. We can delete these 3 nodes. We don't actually need them. And hook that up. And then we'll just scoot this over. And we'll delete the previous transform. And there we go. Okay, so for right now, let's just add a little print string here and say we can do the push exclamation point, and then we'll just make this green for goodness. And then I think that might be it for this part. So let me just make sure we're calling this. So back in the, where was this? Handle. All right, this gets called from the event graph. Okay, so we are calling this. Okay, so let's test out a few situations here. So if we just walk up here, obviously it's in a good spot. Oh, failed. Wall in between character. Oh, did I mess up my line trace? Oh, I must have. What is this hitting? Oh, it's probably hitting the box. Let's double check. Hold on. So pushable. And this is why these print strings are really helpful because it tells us, it failed here. So let's see what this is hitting. I'm just going to do, you don't have to do this. I'm just doing this so I can see what it's hitting here. I think it's hitting in the box. Might have to ignore it. We might have to ignore the box as well. Hit actor. Let's see. Oh, it's hitting the floor. Why is it hitting the floor? Oh, is it because I think our box might be in the ground. So the one thing you have to be careful about with pushable objects is they have to be, oops, that's not what I wanted to change. I was trying to change this. You can change the snapping amount. I'm gonna set this down to 1. You wanna make sure that things are slightly above the ground, or otherwise it's gonna mess up pushing. Okay, so now that we have it slightly above the ground, we can actually push it. Because if it's on the ground, then Unreal is going to think that it's colliding with the ground, right? So it needs to be just slightly, ever so slightly above the ground. And you can see when we press the button, it not only prints out we can do the push, but it puts our character in the correct spot and the correct orientation, right? So you can see it starting to snaps him to the right spot. Okay, and then we can also test some fail cases. Let me actually go undo that real quick, just so it's not so ugly. Okay, so yeah, let's test some fail cases real quick to make sure we did this correctly. So let's move this like over here against the wall. And then we'll hit play. So we should be able to push it from this side, which we can. But if we come like over here and we press it, it's saying no transforms found because I'm not close enough. Let me move it away from the wall so I can get behind it at least. Is that enough room? That should be good. I just want to make sure it's working. There we go. So you can see push failed, no room to stand. You can see because it's drawing that capsule up there and it's detecting that there's not enough room. So I can't actually get behind the box. It's not going to let us push it. And then let's test the one case with a skinny wall. So I'm just going to Alt drag this over. And then I'm going to set the scale to be, let's see, with scale on this axis, 0.1. We're going to make a really skinny wall. And we're going to put it right up against it. And then we need to make it smaller so we can actually walk around it. So we just want to make sure that it doesn't let us try to push this before we continue. So if I come right here, you can see fail to push, wall in between character and object. Okay, so our cases seem to be working pretty well. It's probably good to move on now at this point to the actual push part of it. So let me look at my other project real quick and see what's next. Okay, all right. So the next thing we need to do here is we need to add some code to our push component because that's where the actual pushing logic is going to take place. So inside of our push component, let's see here, event graph. So in the begin play, we want to call set component tick enabled, and we want to leave this as false. So what this is going to do is it's actually going to disable the ticking of this component. And the reason we're doing that is kind of as an optimization, but also because we don't need it to tick if you're not pushing anything, right? There's no reason for it to tick. So the idea is that whenever this component starts being used, whenever you start pushing something, we're going to enable the tick, and then the tick is going to push the object. So if the tick is enabled, it's going to be pushing the object. If the tick is not enabled, then it's just not going to be doing anything, and that's going to save us both computing power, and it's also just a nice way to design it, I think. So by default, we're not pushing anything, so we're going to set it to false. And then the event tick we're going to fill out later, so we'll leave this here. But we can also add a couple events, or sorry, not events, functions over here on the left. So we want to add one for begin push. And so this is what's going to get called basically at the end of that long function we just wrote, once we determine that we can push something. And we need to take in the object that we're pushing. So new parameter, and we will call this the, or sorry, it needs to be of type BP underscore pushable. And then we'll just call this the pushable. And then we also want to make one for end push. So we'll make another one here and call it end push. And we don't need any parameters for that. Okay, so back here in begin push, actually, before we fill this out, let's just call it real quick. So BP pushable, all the way to the right here where we print out, we can do the push. Instead of doing this, we actually want to begin push. So in our local variables, we'll drag in our push component, and we'll say begin push. And the object we're going to be pushing is ourselves, because we're inside of the pushable right now. So we'll say get ref to self, like so. And there we go. So begin push gets called. So inside of here, what we want to do is we want to first of all make sure that we're not currently pushing something. So we'll drag in our current pushable, and we'll say is valid, and this will return. It will be valid if we're pushing something, and it won't be valid if we're not pushing something. So we can say not boolean. And so this is saying if it's not valid, and then we'll do a branch. And the reason I do these knots, you guys are probably just wondering why I do these knots and I don't just drag off the false. I just like it so that the main line of execution just comes off the trues. And the reason I like that is A, because the lines are straighter, but a lot more importantly, because whenever I go and refactor things, I have a tendency, like when I'm unhooking things, I have a tendency to just automatically hook things back into the true without actually reading the code. So I like to hook it up so that, the success value is always the true, but you could do it differently if you want. But anyway, so if it's not currently valid, meaning we're not currently pushing something, then first thing I want to do is you want to get the owner. So the owner of this component in this case is going to be the character player, but it could be like any character in your game, technically. So we'll say cast to character. The only caveat here is that it has to be a character since we're casting it to a character here. Otherwise, it won't work. But so any sort of NPC or player in your game will be able to do this. And so we can promote this to a variable. Actually, let's not do that. Let's delete this. Let's promote this to a local variable because we only need access to it inside of this function. And we will just call this the owning character. And then once this cast succeeds, we can then say it's safe to assume, or we can safe to assume that we're good to start pushing it. So we want to actually save this pushable into our current pushable as well. So we'll drag in our current pushable and set it. And we want to set it to the one that was passed in. So we'll say get pushable. We're just updating this variable to whatever is passed in. And then we want to, so the way we're actually going to do this is we're going to attach the character to the object that he's pushing. I know that might sound a little backwards, but that's just the way that makes the most sense in my opinion. So drag off, or actually just right click and say attach actor to, maybe not. Let's see, let's drag in the owning character and say attach actor to actor. There we go. You might not, a lot of people comment on my YouTube videos saying they don't see this function. Like they change the name of these attach functions a lot, but you basically want the one that's attaching an actor to an actor. So I don't know what it might be called in the version you're on, but you want the one that attaches an actor to an actor. So attach actor to actor, and then the parent actor is going to be our pushable. So you can see we're taking the character and we're attaching it to the object. And then also really important, we want to change these to keep worlds so that the character doesn't change his world space position because he's already in the correct position. Okay, so let's see. So now the character is attached to the box. And there's a couple things we need to change about the character in order to have him function correctly. Because you'll notice a few things change when he's pushing something. The main thing that changes is, let me just run it real quick. The main thing that changes is the way the camera works. So right now, when I rotate the camera, you can see he walks in the direction the camera's facing. But when he's pushing something, the camera is like a free rotating thing, right? And I also can't walk. If I try to press WASD, it doesn't let me walk. So there's just a few things we need to change about the character. So dragging the Oni character, and we want to, first of all, say, actually, I guess we don't need to do this. That's step I'm just reading. I had originally set it up so that it constrains him to the plane that he's moving on, but it won't hurt to do it. We'll do it anyways. We'll say set plane constrain. Let's see. Why is it not? Oh, it's inside of the character movement. Get character movement. So we're basically constraining him to the direction he's moving in. So that way he can't move any other direction. Like, I don't know, if something hit him, maybe he might try to move a different direction. We don't want that to happen. So we'll say set plane constraint enabled and set it true. And then we need to specify the plane that he's constrained to as well. So again, drag off of this and say set plane constrain normal. Oops, not that one. Set plane constrain normal. And so the normal in this case is going to be his right vector, because if you read this, it says sets the normal of the plane that constrains the movement, enforces the plane constraint if enabled, changing the normal. Okay, so that actually is not helpful information. But what this plane normal does is it's saying whatever normal you specify here, he can't move in that direction. So we don't want him moving right or left. Like, it's okay if he moves forward or backwards, or even up and down, but we don't want him moving left and right. So we'll take this Oni character and say get actor right vector, and we will constrain him so that he cannot move on that plane. And then also we want to set it so that for the camera stuff, right, we want to make it so that he doesn't rotate whatever direction the camera is rotating. So we can drag off of our character movement and say set orient rotation to movement, and we want to set this to false because by default it is true right now. And then the last thing we want to do is we want to enable the component tick, right? Because remember, like I said before, the tick's only going to be enabled when he's actually pushing something. So we can say set component tick enabled, and we'll set it to true. And now we are ticking. So if we go to the event graph here, and I'm just going to add a little print string here so we can see what's going on. And we will print out ticking exclamation point. And maybe we'll set this down to 0 seconds so it doesn't spam. All right, so if we hit play and we go up to our box and we press the button, you can see it's now printing out ticking at the top left, and that's because the tick event is being called. So inside of tick is where we want to write the code to actually have him start pushing the thing. So we can delete this little print string here because we don't need that. So the first thing we want to check, and this is really just a safety check, is we want to make sure that the current pushable is valid. So we can drag this in, right click, convert to validated get. There really should be no way that this is not valid since we're only enabling tick when this gets set, but can't hurt to check it. We can then say add actor world offset to actually move the thing, right? So we'll say add actor world. Sorry, we need to drag up this. Add actor world offset. And so we're basically going to move the box. And since the character is connected to the box, the character is going to move along with it. And so the direction we want to move the box in is whatever direction the character is facing, right? So we can say get owner, which is the character, and we can say get actor forward vector. And then we need to specify an amount because this is a delta location. It's not just it's not a direction. So we need to move him in this direction some amount. So we need to say float multiply. And then whatever value we pass here is basically how far he's going to move each tick. So whenever you're doing anything inside of a tick, you need to multiply it by delta seconds. So I'm going to drag off this and say float multiply. And that way he doesn't move faster or slower based on your frame rate is the idea there. And then for the speed itself, we will use the push speed here. So we'll drag in the push speed and hook that up. And then that will be our delta location. So the higher you set this number here, the faster he'll push things. And we can set this to sweep. So this is really important. If you don't set this to sweep, then you'll be able to just push things through walls like infinitely. But if you set this to sweep, whenever the box or whatever you're pushing hits something, it will stop and it won't let you push it through anything else. So really important that you select that there. And so what we want to do here is, well, we don't really need to do anything, but we can add some little print string here. Actually, it's kind of stupid because all I was doing was printing out like, oh, we hit something, but I guess it won't hurt because you might run into the case where you're hitting something and you don't realize it. So this is probably a good debug thing to have here. It'll just take a second. So we'll do a print string and we'll take this and we'll break it. And what we want to do here is drag off of this blocking hit and search for select. And we want to select this one here with the little yellow, like backwards looking E thing, because we're going to use this for the color. Because if it hits something, we're going to print it out as red. Otherwise, we'll do it as this bluish color. So hook that up. So if we do hit something, again, yeah, we want it to be red. If we don't, we can do that like cyan color, whatever color that is. And then the actual message here is going to print out what we hit. So we'll say get display name of the thing we hit. And we'll drag off this and say append. And then I'm going to move this into the B. And then we'll say collided with colon. So most of the time, this is not going to print out anything, or it's going to print out collided with, but then just nothing, because most of the time it's not going to be colliding with something. But as soon as you hit a wall, and I'll show you this in a second, it will print out in red collided with, and then whatever it hit. And this is, again, it's kind of useful because you might have like a little, blade of grass or some weird geometry sticking out of your ground that you don't intend to have collision on. And this will be useful because then you'll be able to see, oh, I'm hitting this weird piece of whatever, and that's why it's not working. And so you won't just be stumped. Okay, so I think that's good. So now let's run this. And we should actually see him, where's this thing? We should actually see him pushing it. So there we go. So you can see, it's kind of hard to tell. There we go. So I am pushing it. We're going to hook up the animation here last. But it is pushing it, and he's doing it kind of slow. And so, for example, if we do, let me push it, let me move it over here, and then push it towards the wall so you can see when it hits something. So you can see at the top left, oops, I'm not close enough. See at the top list is collided with, and then colon, and there's nothing. And so this is normal. It's colliding with nothing. But as soon as I hit this wall, you can see collided with wall 10. Yeah, so it says collided with wall 10, and we're now stuck here because we don't actually have a way to stop pushing it. But I just wanted to show you that, to show you what that print string was for, and also that it stops whenever it hits the wall. So now we're almost done. The last two things we need to do, I think, is we need to hook up the animation, and then we also need to make it so that you can stop pushing it, because right now you can just kind of push it forever and you don't have a way to stop. We want to make it so if you press F again, he stops pushing it. So that was the last two things we'll do, though, and we'll do that in part 4. So I'll see you guys in part 4.